In this video, we'll be looking at the MatrixSpiral interview question in Java. My name is Larry, and this is Digital Logic. To get started, you'll need to download the project from GitHub. A link is in the description below. I've also provided a link to the introduction video to the series, which will walk you through setting up your development environment. With that out of the way, let's get started. So I've already got the project open in IntelliJ. So I'll open up the project browser and then open the MatrixSpiral class. For this challenge, you need to write a function that will return an n by n matrix that spirals clockwise, starting at position 0, 0 with the value of 1 and ending at the value of n squared. The following examples demonstrate the expected output for the provided input. Once you have a solution that you're ready to test, press Ctrl-Shift-T to open up the testing class. Then click on the little icon next to the class name to run the test. The testing class will pick up any public method that you define that matches the expected signature, so you can provide multiple solutions, and the testing class will test all of them. If you want to attempt to solve this challenge without any hints, then pause the video now. When trying to solve a problem like this, one possible approach to take is the DIY approach. And what this means is to first try to solve this problem on paper, and then take that logic and transform it into code. So we need to start by creating an example to work with. The example needs to be large enough so that we can see what kind of problems that we'll run into, but small enough so that it's easy to maintain. A 3x3 grid isn't large enough because we won't have to deal with the inner loop, but a 4x4 grid is perfect. So I'll start off by creating a 4x4 grid to represent my two-dimensional array. In Java, a two-dimensional array is nothing more than an array of arrays. To access any one point within the grid, you have to use two array accessors. The first one defines which inner array to access. This defines the row, or the y-axis. The second one defines which element within the inner array. This defines the column, or the x-axis. This is probably opposite to what you're used to, but in a two-dimensional array, the y-axis is specified first, followed by the x-axis. With that out of the way, let's start filling in this matrix. So I'll start at position 0, 0 and fill in the value of 1, and then move to position 0, 1 and fill in the value of 2, and then move to 0, 2 and fill in 3, and finally move to 0, 3 and fill in 4. We could create a simple for loop to fill in this top row, and then create another for loop to fill in the right column, followed by the bottom row and the left column. But how can we make it work for the inner loop? The problem is what to set as the start and stop positions for the loops. It's mostly limited to what has already been filled in. For instance, when filling in the right column, we would start at position 1, 3 because the top row has already been filled in. To solve this, I'm going to create 4 new variables to function as boundaries: top, bottom, left, and right. These variables will provide the start and stop position for our loops. So we start at the top left corner, defined by the top left boundary, and then move to the right until we hit the right boundary. When the top row is filled in, we move the top boundary down. The top and bottom boundaries now define the start and stop positions to fill in the right column. When the right column is filled in, we move the right boundary. We continue this process until the grid is filled in. Alright, that is it for your hint, so go ahead and pause the video now and try to come up with a solution to this challenge. When you're ready to continue, come back here and we'll walk through the solution. Welcome back. So I'll start by creating my grid as a new final init array, and I'll name it grid equals new init array. And the size of the array is going to be n by n. Now I'll create the boundary variables. Top equals 0, left equals 0, right equals n minus 1, and then bottom equals n minus 1. Now create a new init, index equals 1, and then create a new final init, max equals n times n. I'm going to have to create a loop to handle each spiral within the grid, but I don't want to define it just yet, so for now I'll just use some curly brackets. And now let's add in the logic to fill in the top row. So I'm going to create a new for loop. Init I equals left. I is less than or equal to right. And then increment I. Grid at top, since we're working with the top row, and I equals index plus plus. When accessing the elements in a two-dimensional array, we have to specify the row or the y-axis first, followed by the column or the x-axis. And then the increment operator is behind the index variable. This is called the post-increment operator, and what that means is that the current value of index will be stored in this grid position, and then the value within the index variable will be incremented. Since we filled in this top row, we need to increment the top boundary. And now we need to fill in the right column. Create another for loop. Init I equals top. I is less than or equal to bottom, and then increment I. And now fill in the grid at position I and right equals index plus plus. Once the right column is filled in, we need to decrement the right boundary. And now fill in the bottom row. So create another for loop. Init I equals right. I is greater than or equal to left. And then this time, we're going to decrement I. And then grid at bottom and I equals index plus plus. Now we need to fill in the left column. So create another for loop. Init I equals, and I forgot to decrement the bottom boundary, so I'll do that in a minute. The execution condition will be while I is greater than or equal to top, and then decrement I. And then make sure to decrement the bottom boundary after we fill in the bottom row. And now let's fill in the left column. So grid at I and left equals index plus plus. And then increment the left boundary. And then at the end of the function, we just need to return the grid. All right, so there's one step left, and that is to complete the outer loop. So for this, I'm going to create a while loop, and the condition will be while index is less than or equal to max. That should do it. Press Ctrl-Shift-T to open up the testing class, and then run the test. And it's passing the test. Well, that is it for this video. If you like this video, then please like, share, subscribe. If you want to support the creation of these videos, then check out my Patreon page. A link is in the description, and I'll see you in the next video.